Okay, so as you can see, it takes a little while to boot up, but once we are done, we can see that, for example, I have loaded the driver for the FIR IRQ. I've also loaded a driver for the smart timer, but that's because it's there in the device tree, right? I actually don't have it in the very later co-simulation. So the interesting thing is that if you go into the smart timer driver and look at the values that you have over there, you will find that they don't match with what was be there in the hardware, because it's not actually backed up by a hardware module, right? But it doesn't matter, the focus of this demo is for the FIR part of it. So let's get into that platform folder, right, the devices folder corresponding to the FIR filter. And what I see over here is I have a number of different things. I have the coefficients, I have the control, I have data in, data out, and the length and the status, right, apart from a bunch of other things that are automatically there as part of the driver. So I can look at a few things. For example, I can look at the status and it says 02, right, done is equal to 0, but it basically also has this particular value of 02, right, that corresponds to whatever is the default state that the FIR RTL has. We will have to go look at the RTL to know exactly why that value is there, right. Now I can look at certain other things. So for example, as we saw over here, right, I cannot, if I look at something like control, it is defined as a write only sysfs attribute, and therefore I can't read from it, right. I also cannot read from the data underscore input, right, it says permission denied. If I try right now reading from data underscore output, I will find that there is nothing, and the reason for that is because the length, the number of data inputs that I have given so far is basically 0, okay. On the other hand, I can basically look at the coefficients by default values, right. I have essentially loaded them all with 0x2000, which is I think 0.25, right, corresponds to a value of 0.25. So this would more or less just average the last 4 values that you write into it, right. So in the steady state, what I would find is it would be the average of the last 4 values that is coming out as the filtered output. Now what that means is I should now try to write data into the data in, activate the filter, right, and then see how it basically goes about doing the filtering, right. So let's do that. I'm going to basically go ahead and write a few values. These are just decimal values that I have over here, right. You can put anything. I'm just putting this as examples out here. I'm writing it into, oops, yeah. So I have written something into data underscore in, right, and if I now look at the length, I can see that it has become equal to 4, right. So clearly some kind of processing has happened. Now I can look at the interrupts out here, right, and what I find is that it defines 43 as the FIR filter interrupt, and well, 0 interrupts have occurred so far. I haven't really done any processing, okay. Now let me start things off, right, as a first cut demo, and the way to do that would be to basically say echo start greater than the control signal. Now what is the start? It basically is just a string. Why I am doing this is because inside my control sysfs attribute, I have written it in such a way that it checks for that particular string start, and if that happens, it basically sends a control start and enable signal, whatever is required for the hardware to start, right. So rather than sort of explicitly writing 1 or 1 1 or something like that into it, I use a more user friendly approach. So it starts, and I can then go and look at the interrupts out here, and you can actually see that it has already raised the interrupt, right. So it's finished the filtering, right. And if I now look at the value in data underscore out, I'll find that this has in fact performed a little bit of filtering, right. There were only 4 values over there, but it has filtered them and it has come through, okay. Now I want to try something a little bit more complicated, so I'm first going to reset the filter, right, by essentially sending the string reset into the control file, and I can verify this by basically looking at the length which has got reset back to 0, right. Now let me write in a few more values. I am basically just repeating the same data again and again, right? And what happens as a result is each time I do that, it appends to the data underscore in, which means that now my length has basically become equal to 12 values, okay? I'm going to start this off, right? And before I do that, I want to very quickly look at this. I have a character device, right, that you can see over here. There is this character device which is called /dev/FIR0, right. Now what is that? Once I finally try reading from FIR0, right, once I get the interrupt, right, I am going to find that I can actually read from FIR0 and get the value back. How exactly does that happen? Well, that was part of what the driver was doing, right. The read function was waiting on the event that the done signal has happened, and as and when it gets the done signal, it reads content, prints and just dumps it out into the screen. The problem with that read operation is it actually just does a binary read. It basically takes values as and when they come and sort of sends them off as direct binary values without converting it into ASCII codes or anything of that sort. And that is not easy for us to read because it will be all kinds of numbers and how they get displayed on the screen is not very clear. So just to make things a little easier, I am going to use this another function out there which is called xxd, which will basically do a hex dump of whatever it reads out from the FIR file. But before that, what I want to do is I want to start the filtering, right. So I am basically going to put in this start greater than control, and you can see that it immediately returned. But now if I type in xxd/dev/FIR0, well, it's actually completed things, right. Let me just try it with a little bit more data, so to see if it can take a little bit longer to complete, right. The interesting thing that you can see if you look closely at this is it has generated all of these values, and if you count them, there are exactly 12 values that have got printed out over here, right. How did it get these 12 values? It basically read out 12 different 16-bit numbers and printed them out over here, right, because that is the number of values that it has got back from the FIR filter. Okay. We will just try this once more with a little bit more of data. So there are like 24 values in there, right. Hopefully this takes a little bit longer, enough to at least show us that we are waiting for the interrupt. I am going to start the filtering, and directly you can see that it waits for a little bit of time, right, and after a short while it basically comes out with 24 different values. How did it do this? Well, let's go and look at whether an interrupt happened or not, and you can see that now the interrupt count is basically 3 because I have actually run the start filter processing 3 times. Each time it completes the processing, generates an interrupt, and the xxd or cat or any other thing that you use in order to read from a file would respond correspondingly after that, right. So the point of this demo was to show that we have sort of split up the work, right. Our main IRQ handler was very fast. It deferred any other processing that you need to do, including sort of displaying data on the screen, to a separate part which is basically reading, and it waits on an event which is generated by my IRQ handler, right. And the use of those variables inside the IRQ handler, the processing and done, can be useful in terms of sort of ensuring that we are able to trigger an appropriate task at a later point in time.